In the next part of our lesson, we're going to take a look at scientific notation. And first we're going to talk about regular notation. Regular notation, greater Rn, is the standard way that we write our numbers. For example, 208 million is written as 208,000,000. Okay, that's how we would write it in its standard form, right? 208 million. The scientific notation is a shorthand way. Of writing really large or really small numbers. In scientific notation, Sn, a number is written as the product. It's written as the product of two factors. The product of two factors. And so if I have this number, this is 280 million. In scientific notation, the first factor would be 2 8/10. And then I would multiply that by an exponent or power of 10. 10, in this case, would be raised to the 8th power. Okay, so the first number, this first factor, the 2 8/10, it's a number that's between 1 and 10. A number that's between 1 and 10. It may or may not be a decimal number. In this case, it is 2 8/10, but it could sometimes just be a whole value like 2. The second factor is always a power of 10. Always a power of 10. The exponent tells you how many places to move the decimal point. The sign of the exponent tells you which direction to move it. Okay, so if we're going from regular notation into scientific notation, if the decimal is moved left, then the exponent will be positive. And if the decimal is moved right, then the exponent will be negative. Okay, and again, this is going from regular notation into scientific notation. So for this number, 420,000, my decimal point is here at the end of the zeros. I have to create a number that's between 1 and 10. And so to do that, I'm going to have to move my decimal point so that it's right here as between 4 and 2. So I'm going to count 1, 2, 3, 4, 5 times I moved the decimal. So this is going to become 4 2/10 times 10, and I moved it 5 times. And it's going to be a positive 5 because I moved my exponent to the left. Okay, I'm going to compare that to this example down here. All right, again, I've got to try to create a number that's between 1 and 10, so my decimal point's going to have to go right here, so that my first factor is 8 97/100. Times 10 to what power? Well, I moved it 1, 2, 3 times. But my 3 in this case is going to have to be a negative because I moved it to the right 3 times. So I get 8 97/100 times 10 to the negative third power. I can also go from scientific notation into regular notation. All right, so our rules are going to be a little bit reversed from what we did in that example. So for example, this time, if the exponent is negative, then I'm going to move the decimal to the left. Okay, and I'm going to add any zeros when needed. But if the exponent is positive, well, then I'm going to move it to the right. And again, I'm going to add any zeros when needed. Okay, so in this example, I have 7 5/10 multiplied by 10 to the 5th power. So I'm going to have my 7 5/10. And since the exponent is a positive 5, I'm going to move the decimal 5 places to the right. So I'm going to go once, twice, 3, 4, and 5 times. All these empty spaces I'm going to fill with a 0. And 1, 2, 3, I'm going to put a comma right there. This is the number 750,000. Compare that with this example right here, 4 2/10 times 10 to the negative third power. Well, I'm going to have my number 4 2/10. But this time, because my exponent is a negative 3, I'm going to move it 3 places to the right. So move it once, twice, 3 times. There's my decimal. Fill in with zeros, all those empty spaces. Okay, and this is the number 42 10,000ths. In the next part of our lesson, we're going to talk about operations with scientific notation, starting with multiplication. When multiplying numbers written in scientific notation, multiply the first factors, and then use your exponent rules to determine the power of 10. Make sure that you rewrite the product of the first factors as a number between 1 and 10, if necessary. So in this example, I have 3 and 2/10 times 10 to the negative third power, multiplied by 2 and a tenth times 10 to the fifth power. I'm going to start by multiplying the first factors together. I'm going to have 3 and 2/10 multiplied by 2 and 1/10. And when I do that multiplication, I get 6 and 72/100ths. For my powers of 10, I'm going to do 10 to the negative third power times 10 to the fifth power. And remember, with same bases, if I'm multiplying, I can add these exponents together, so this is going to become 10 to the second power. And so when I rewrite this now in scientific notation, I have 6 and 72/100ths times 10 to the second power. All right, in the next example, I'm going to, again, take my first factors and multiply them together. So I'm going to have 4 and 5/10 times 6 and 1/10. That's going to give me the number 27 and 45/100ths. Okay, and now with my powers of 10, I'm going to have 10 to the negative fifth power times 10 to the 8th power. And again, I'm going to add those exponents together, which is going to give me 10 to the third power. Okay, and so right now I have 27 and 45/100ths times 10 to the third power, but this isn't in scientific notation because this first factor isn't between 1 and 10. So I'm going to have to move my decimal point 1 place to the left, which is going to make this number 2 and 745,000ths times 10. Okay, well, since I moved this 1 place to the left, that's going to increase my exponent by 1. So that's going to become an exponent of 4. So we get 2 and 745,000ths times 10 to the fourth power. Next, we're going to look at division. When dividing numbers written in scientific notation, divide the numerator by the denominator, and then use your exponent rules to determine the power of 10. Make sure that you rewrite the quotient as a number between 1 and 10 if necessary. So in the first example, I'm dividing 6 and 4/10 times 10 to the 6th by 1 and 7/10 times 10 to the second power. So I'm going to start by dividing my first factors, 6 and 4/10 divided by 1 and 7/10. And when I do that, I get a really long decimal here, 3 and 7647058882. Next, I'm going to look at my powers of 10. Well, I have 10 to the 6th divided by 10 to the 2nd. And remember, when the bases are the same and you're dividing, you can subtract the exponents, which is going to give me 10 to the fourth power. So written in scientific notation, I'm going to have that really long decimal number again. And then I'm multiplying by 10 to the fourth power. Okay? In the next example, I have 4 and 5/10 times 10 to the third being divided by 9 times 10 to the negative 7th. And again, I'm going to divide my first factors first. 4 and 5/10 divided by 9 is going to equal a half, or 5/10. And then for my powers of 10, 10 to the third divided by 10 to the negative 7th power. Well, again, I'm going to have to subtract in order to come up with my power of 10. 3 minus negative 7 is 10. So I have 10 to the 10th power there. So right now, my answer says 5/10 times 10 to the 10th power. But again, my first factor has to be a number between 1 and 10. And so I'm going to have to move my decimal point once to the right, making my first factor a 5, times 10. Well, since I had to move this 1 time to the right, that's going to decrease my exponent by 1. And so I'm going to be raising it to the 9th power. So I have 5 times 10 to the 9th. On the next few pages are some practice problems that I'll have you work through evaluating operations with scientific notation.